Welcome back, chemistry fans. This is the second part of Unit 6 exam. These are the free response questions. There are 4 of them that we need to cover. So let's get right into those shapes of the molecules. How do we draw those shapes? So let's find out here. Okay, so the first one, it's asking us to draw CFP. So let's get into it here. CFP. Let me find a little space down here, CFP. Okay, so we know the first element goes in the middle. It doesn't matter if you put the C on one side or you put the P on the other side. That just doesn't really matter. So I've got it the way I'm, I'm just going to put it in this order. Doesn't really matter. I'm then going to go with 1 minus half. There are 3 atoms. They each want 8. That is a total of 24. The half pile is 5 plus 7 plus 4. I get those from the valence electrons that are on the periodic table. That means that there is a difference of 8. Now, the 8 can be divided by 2 to figure out that there are 4 bonds. Now, normally you would put them 2 and 2, but that's not the case for this one because fluorine is a halogen and it can only have a single bond. So this is the shape of this is the Lewis structure. Now the shape of this needed to be drawn more 3-dimensionally. Now there's not much of a difference between this and the one above because it's both a linear molecule. Okay, so that was the first task that you had to do. Now number 2 or number 8 on this one, we are doing OF2. Again, I'm just going to put the first element in the middle, and it doesn't matter which one you put on the sides because they're both the same. Now, I do know that because they're halogens, they're both going to have single bonds. Now, I could short circuit this process, and I could say, oh, we're going to have these unshared electrons on the top and on the bottom. If you wanted to put them both on the top to try and emphasize the fact that it's going to bend away from it, that's fine. But you needed to at least dictate and tell me that the fluorines are halogens. So I'm going to do 1 minus half in lieu of just assuming and understanding that they're halogens. There are 3 atoms. They each want 8. That is a total of 24. The half is going to be 14 for the 2 halogens and 6 for the oxygens. That's a difference of, or that's a total of 20. For a difference of 4, you divide that by 2 because every bond has 2 electrons in it, and I get 2 bonds. So then again, what this shows me in my Lewis structure is that I have these 2 unshared pairs of electrons, meaning that what it's going to look like more 3-dimensionally is this bent structure where there is repulsion. Okay, I'm moving on to my final 2, question number 9. Now, this one changed multiple times because I kept screwing up what the shape of what the formula for the molecule should be so it would work out nicely. I think I finally have it, though, correct right now. So let's jump through this one. If you missed it on yours, just talk to me about that and we can see if there was still correct work in it and we can get you some points back. If not, just make your corrections right now and you get full credit either way. All right, first element goes in the middle, P goes on one side, O's go somewhere else. And it doesn't matter how you lay it out. They're all equivalent points, however you want to do it. Let's do 1 minus half. This is not a expanded octet. There are 4 atoms. They each want 8. That is a total of 32. Then the halves, 6 for the sulfur, 5 for the phosphorus, and 12 for the 2 oxygens. Plus there's 1 more that was added in. So that is going to be a total of 24. The difference there is going to be 8. Divide that by 2, and you get 4, meaning that there's going to be one of these atoms that has a double bond on it. This is meaning that this one is going to be trigonal, planar, and what it's going to look like, again, is not too much different from the Lewis structure. You need to be able to show me that you understand they're going to split apart. You're not going to have all this big open space underneath it, that they're equidistant. Each one of these distances are equal from one another. All right, now, last one is an expanded octet. I tell you that, so that should indicate you are not going to do 1 minus half. You are only going to do half. I'm going to put my first element in the middle, selenium. I'm going to put chlorines around and F's on around those. I know that they're all halogens, so I know they're all going to have single bonds. However, let's figure out if there are any extra bonds that are floating around or extra electrons that are floating around. So I've got in this one 4 atoms that each have 7. Those are my halogens, plus 6 more for the selenium. So that is a total of 34. I have 2, 4, 6, 8 for the bonds. So that means I've got 26. Now, each one of these atoms, these chlorines and fluorines, they each want 6 extra electrons to fulfill their stable octet. That's going to subtract 24, meaning I have 2 extra electrons that need to go in the middle. What is this shape that has 5 parts around it? Well, what you are going to end up with is your trigonal bipyramidal. So the name of this one is trigonal bipyramidal. And so if you could draw a structure that looks more like this, that would be the correct 3-dimensional structure that I was hoping that you would tell me. All right, this is everything that I wish to share with you. Thank you so much for staying with me. Hopefully you understand a little bit more, explain your process, and we'll talk to you again soon. There's the bell. Bye.